Hello everybody, this is Dr. Elek again, and today I will talk about experiment number 2. It is about B2Spice, and B2Spice is a software that you need to install it. It is on Canvas. You need to install it in your computer, and it will be used to simulate any circuit and also do the measurements. So it's very important that you have it and learn it, and it's very simple too. So this experiment will have this circuit, and we need to build it and find the voltage V0 and I0. So let us see how it is working here. Everything is explained in details in the experiment. So for example, the first part is how to build a circuit in B2Spice. So open B2Spice, and then this is how we do it, B2Spice workshop. So I have it here in the desktop. So let me open it. So here's how it looks like. B2Spice. Okay, and then we press new, select new workshop or new sheet. And then we use this menu, use the menu, say here use menu, or workshop parts chooser to add devices to the workshop, to worksheet. So as you see here, there are some menus, the devices, and also under this part chooser here, you see this is workshop, workplace part chooser. You can select any device that you want to add to the worksheet. So we need to make this circuit here. So let's see how we do this in B2Spice. So we go to devices, and for example, we need to do a circuit, a resistor. So we have a resistor here. Select resistor, and you click here. Okay, I want a resistor here. Okay, how does the circuit look like? It has the circuit look like this. Here it is. So it has two resistor, and two resistor, and here one resistor and source. Okay, so let's just do it like this. So we can keep adding device like this, resistor and the resistor, or we can copy and paste. So we can copy and paste, copy, Control C and Control V. And all these shortcuts are you will find it on the experiment. There it is. And you need to add another one, Control C and Control V. If you want to rotate, you can go to Edit and Rotate. There's a C, rotate, vertical or horizontal or clockwise, whatever. Or you can just press Control R, and you can click and move it like this. Then you can copy this one and move it here. You can copy this too. Copy when if you want multiple select, you can select like this, or you can just press Shift and click. So Control C, Control V, and here it is. You can add another one here. There it is. So now we have all the resistors. And as I said, everything is explained in the experiment here. See, here you have the shortcuts. Control R is rotate clockwise. Control Shift R is rotate counterclockwise. Control C, Control V is copy and paste. When you press Shift, you can select multiple devices. Okay, and then we need to add a source. So you need to go to device and voltage source. The voltage source is here. Where's the voltage source? Here's the voltage source. And there's a ground, there's a current source. So let's select voltage source. The voltage source is here. It's very clear that you have positive and negative. Then you need to rotate. Control R again. Here it is. You can move it like this. Then you have now all the elements. Okay, you need to add also ground, but you can add the ground at the end. And then now we just need to connect the circuit. So connecting the circuit using these wires here, wire tool. So you select, for example, click, another click, and to end, double click. Okay, you see here, you don't have anything. If I click, but it's moving with me, see? Okay, so you don't, once you double click, it ends. Of course, if I want to select, I have to press this arrow and then select all this and then delete it. Now, let us draw another arrows like this one here, and this one. Click this one, connected to this one. Click, double click, and click, double click. Okay, now we're done. If I click anywhere, I will click. I will have a wire here, so you don't need to do that. So you need to double click and then select this one. You can select this wire and delete it. Okay. Then now, what we need to do is to add a device like a ground. Usually, we need to add a ground in the bottom like this. So now we have a ground. Once we have a ground, okay, you will have numbers for the node. See here, we have this 0, for example. This node is 0. This one is 0, 0, 0. This means what? This means that these 3 are connected together. They are all 0. Okay? These 4 are connected together. When you look at them, this is 11, this is 11, this is 11, this is 11. These 3 are connected together. 3, 3, 3, and so on. So you must check that all points are connected. If by mistake, for example, let me delete this one and delete this one. Okay? If by mistake you connect a wire like this, you see, double click. Now what happened? Okay, what happened is that this point is 4, this point is 4, and this point is 4 also. This means that you are shorting the resistor. You are connecting a wire over the resistor. So you have to be careful not to do that. We need to delete this. Okay, and then we need to connect wires again. So here it is. Double click, and then click, and then double click. Now already when you click on the worksheet, it will show the numbers. So you see now this 4, 4, 6, 6, and so on. So now we have all elements right. When you go to simulation, you must select setup simulation, and you have to select this O.op, this point here, this one. Enable it. Why? This will help you actually when you run the simulation. It will show the voltages at these nodes. So node number 5, number 11, number 3, sometimes it's helpful. So if you want to select to show the videos, the voltages at the nodes, you need to enable this .op. If you have AC, like sine wave, you need to enable this one here. Transient and Fourier analysis. We'll go to this later on. But you don't have any right now. So press OK. We can run away. We can run it from here also. Run the simulation. If you don't see these nodes, you have to go to view and see show node numbers. Now you don't see the node numbers. So it is very helpful that you see the node numbers. So we have to go to view and enable show node numbers. Now we are ready. Okay, so now let's go here and compare it to the ones that we have in the experiment. So we're done with this. Okay. So now we need to make sure that we have the right values. For example, here, if you look at this, we need to have the right values. So we need to have 1, 3.3, and so on. So how we do that? And we need 15 volt for the source. So what you need to do is just double click. When you double click the source, you have this constant here. It is a constant DC. You select the what kind of source. It is a DC, so it's constant. So it's not sinusoidal, not exponential, not pulse. We need constant. And its value is 15 volt. 15 volt. So now we see it show 15 volt. You click this one here, make it 4.7, 4.7, and then OK. As you do the same for the rest. This one is 3.3K. This one is 1.1K. Yeah, it is 1K already. This one is 2.2. This one is 4.7. It doesn't matter if it is small or capital. This one is 2.2. This one here is this 1K. Don't have to change. This one is 1.5. The last one here, this one is 1K. So now we have 1K, 1K, 2.2, 1.5, 2.2, 3.3, 4.7, and 1. And this 15 volts. So now we are ready. We have the circuit now. Okay, so now let's go to the next part. So we changed the resistors. So we go to simulation, and then we did this already. So we have to make sure that we have all the nodes connected together. Sometimes, see, we don't see this green. It is a green here, but it's not very clear. But you must have the same node numbers when the nodes are connected, like here, like this 11, 11, 11, 11. Make sure. If they have different numbers, this means that they are not connected. Okay? So this is a check for you to do that. Then after that, we need to run the simulation. Okay? If you run the simulation, let's see here. Okay, before we do the measurements and everything. If you run the simulation, you just press these two arrows, green arrows, or you can just go to simulation and run, or press F5. You have many methods to run the simulation. So do this, or you can just click this run. When I run the simulation, you see here we have the voltages. Shows the voltages at the nodes. So let us open this. There it is. You see, for example, the voltage 17. Where's 17? 17 is this node here. This node. So this 17. The voltage across 5, for example. 5 is the source. It is 15 volts. So I know that V5 is 15. V5 is 15. Here it is. If I need the voltage across, for example, the 4.7 ohm, kilo ohm, whatever, any voltage, I can find it here. V3, V11, and so on. All the nodes are here. Okay? But in the circuit that I have, I need to calculate the voltage across the 4.7K and measure the current in the 2.2K. Here it is. See, I need this voltage and I need this current. So how we do that? You add a voltmeter, which is a very helpful tool. Voltmeter and a meter. The voltmeter you connected in parallel with the resistor, like this. This is a voltmeter. So we call it here shunt connection. And the ammeter is connected through the wire. So actually what you have to do is to disconnect the branch and then insert the ammeter inside it, like this. And in the direction of the current. Okay, that's it. So let us do that. And once you run the simulation, it will show the value inside the device, the ammeter or voltmeter. So let's do it. So for example, here you need to add a voltmeter, say device, and then voltmeter. It is horizontal or vertical. In this case, it is vertical. And make sure that you connect the positive and negative depending on the value. See, V0 has a positive in the top, negative in the bottom. So this one is also positive in the top, negative in the bottom. And then you connect this by wires. Double click, and then here you connect this one to this one here. Now we're done. Okay, if you want to make sure, you must have the same number, 7 and 7, 5 and 5. Let us add also ammeter. You need to add ammeter. The ammeter, you need to add a device here, ammeter. It is horizontal or vertical. In this case, it's vertical. Okay, so we need to add it here somewhere. So what we need to do is just we need to move, for example, everything is down, move it down a little bit. Okay, and then we break the circuit here, delete this, and then insert our ammeter inside like this. Okay, and then we need to connect a wire here between this one and this one. Now we are done. You see here we have this ammeter. Let's move this a little bit here. Okay, you see this is the ammeter. Oh, what happened? Okay. So now you see is you have this 11, 11, 11, 11. They are all connected. And now the other terminal of the multimeter or ammeter is connected to the 2.2 kilo. So when you run the simulation now, it will show VO under VM, okay, and it show or inside VM, and it will show the input current or the output current IO under VAM. So let us run the simulation and see. So it will show it here inside this here. The voltage is negative 3.1.91 and the current is 3.76 milliampere. This is the current and this is the voltage. Okay, it also will show up also in the result here. As you see here in the bottom, you will have V as a voltage of VM1, which is the voltmeter, and this is the current of the ammeter. So here 3.91 negative and 3.76. So let's go to the experiment and we'll see the same values. Okay, so this is what you need to do. As I said, you will have the current. Okay, this is the so it's supposed to be in the bottom here. I have to move this down. This is the current in the ammeter, and this is the voltage in the voltmeter. So this is supposed to go down. It's supposed to go down. So these 2 points are not right. Okay, this is the ammeter. Here's the ammeter, and this is the voltmeter. You have to change this. Okay, what if you want to add current? You want to add current. Current is a little bit confusing. Okay, so why? Because in the speech spice, it look like this. It has a positive and negative. Which for me, it doesn't make any sense. I don't know why they have it like this. But it's very important to understand what is this positive and what is this negative. If you have the current 5 ampere, for example, like this, okay, so you must have the negative in the top and the positive in the negative in the bottom. If you have 3 ampere, for example, like this, then it will be positive here, negative here. So the current in P2 spice from positive to negative. Why? I really don't know. But then you need to add a current, for example, like here, see? If you need to add a device, here you add a device, and then you add a current source. Then the current source will look like this. So according to this, the current is moving from the positive to the negative, from negative to positive. What's it? From positive to negative, yes, from positive to negative, like this. Okay, so this is how they do it. Then what you need to do is just double click this one here and change the value. 0 ampere, make it, for example, 5 ampere or 3 ampere, whatever. So, okay, so now the current source. This is a current source. Okay. Then this will conclude this experiment. What you need to do later on is to do what is to do this experiment. So we need to do this circuit using P2 spice. Exactly the same. We add the source and we add these resistors. And of course, in this case, we'll have nodes. This V1, V2, V3. They are nodes. Then once you run the simulation, you will find this V1 and V2 and V3. Of course, the numbers will be different. Okay. Then to calculate the current or VO, you just need to add a voltmeter and a meter to this. So for example, if you want to do this very fast, so let us erase everything. Let's erase everything here. Delete. Okay, so then we just need to add volt source again, device, as in volt source. There it is, and rotate Ctrl R, and then you add number of resistors R. Here it is R1. This is 2.2, and then 6.8, and then 2.2 again, and then need to add a 4.7. Rotate it, 4.7, and then you need to add 10K. You need to add 7.8. Then double click them. This one is 2.2. This one is 6.8. This one is 7.8. Make sure you have this K. Okay. And this one is 2.2. This one is 10K. And this one is 4.7. So now we have the circuit ready, and this is 5 volt. 5 volt. Then we have almost the circuit is ready. Then you just need to add the connections. Click and double click. And then you add a ground. You can add it anywhere. Now you have all the nodes are clear now. See? So now we have, you see, this 11, 12, 3, and 5. So V1, for example, is 11, V11, and V2 is V12, V3 is V3, and VO will be the voltage across this resistor here. Then what you need to do is to add a meter to measure the current and voltmeter to add the voltage. So let us do this. We can break the circuit, as I said before. Break the circuit and add a meter here. Device, and then a meter. There it is. And then you can connect it. Okay. So now you have this emitter. Oh, okay, no problem. You see now we have this emitter. You can move everything again down. So now I have this emitter, and I want to connect the voltmeter, device, and voltmeter. Where's the voltmeter? Here it is, vertical. And you can add the voltmeter across both, or you can just make it across only the resistor. Okay, let's make it across the resistor. So here, now I have, this is a voltmeter and this is the emitter. So now this will measure IO, this will measure VO. And now we just need to run. So go to simulation, and then make sure that you have this OP again, and make sure that you have what else? You show the nodes, of course, and then you run the simulation. Run the simulation. When you run the simulation, you will see all the values. Oh, come on, what happened? Yeah, here it is. You see here that we have this V5 and V4 and so on. So V11 was V1. V1 is 5 volt. We know this because it's a source. V12 is V2. V2 is 2.747 volt. V3 is V3. So where is V3? V3 is here. It is 2.74 also to something. And then the last voltage here is a voltage across, or VO is 1.87 volt, and the current is 397.49 microampere. This is the current. Okay, so this will be the circuit in the exercise. So now build the circuit. We did that. Find the V1, V2, V3. Measure VO. Measure IO. And then calculate IO from VO using ohmmeter. Using Ohm's law. If you want to calculate the current, how do you calculate the current? Let us see. According to this, let's see. We have the calculator. Let us measure or find the current using Ohm's law. Ohm's law, this means the current equal 1.87 volt divided by 4.7 kilo ohm. Okay, kilo ohm. So it is the current will be in milliampere. The current will be in milliampere because the resistance in kilo ohm. So the resistance, the result is what? Is 0.9397872 and so on. 0.3797 milliampere, which is the same like 397 microampere. Of course, there's little bit difference here. It's okay, no problem. Okay, but the difference is not it's not huge. There's no difference actually. Okay, then next part is that we need to change the voltage of the source to 10 volt and then repeat step number 3 and 4, which is the measure. Let's see. Before we do that, let's see what is expecting. What's expecting? So if we change the voltage here to 10 volt, 10 volt. When we run the simulation, what do you expect? If we double the voltage, the source, if we have only one source, or if you have multiple sources, okay, then in this case, it will be, you will double the result. You will double the measurement. So instead of 1.87 will be what? Let us see. Will be 1.87 times 2. 3.74. Let us see. Let us see. So now let us run the simulation and see the voltage. Okay, so you see here it is 3.74. And also you double the current. Okay, why? Because this is what we call it linearity. This is linear circuit. That when you double the source, you double the resistance or the output or input, the output currents and voltages and so on. Let us see the what's next here. Now when we replace the voltage source and the left 2.2K with 2.27 milliampere current source like this. Okay, so we need to replace this part with this current source parallel resistor, and then we repeat 3 and 4 again. Okay, so let's see. So now let us see if we go back. So we replace this volt source, okay, and this 2.2. So let's remove everything. So this one will be rotated like this, 2.2K, and then we add wire. And then we add a current source device and current source here. And so here's the current source. So let's move everything to move this a little bit here. So we have this current source and then we connect wire. Oh. Okay. So now we have the wires. Okay, so now we have this current source and we have 2.2K, but instead of the 2.2K and 5 volt. And it makes this 2.27 milliampere. So let's go here and make this 2.27 milliampere. Then here it is. And then we run the simulation again to measure the current and voltage. So let's see what's the result. What is the result? Is 1.87 and 397 microampere. This is the same result which we got before for 5 volt. Which means what? Okay, you see here we replaced the volt source with a current source. But what happened? We got the same result as before, as in steps number 3 and 4. So what does this mean? It means that these two are the same or equivalent to each other. It means that they are equivalent to each other. And this is what we call a source transformation. We learned this in chapter 4, the circuit class. So if you have a voltage source in series with the resistor, this is equivalent to current source parallel with the same resistor. And the relation between current and voltage is Ohm's law. Voltage equal current time resistance. So now if you calculate this, if you multiply the resistance 2.2K time the current, which is 2.27, of course K will cancel with milli, then the result is 4.994, which is almost 5 volt. It's almost 9 volt. Okay, so this means that these two are equivalent to each other. Next time we will talk about experiment number 3. Have a nice day.